All right, in this video, we are going to be talking about percent of change. And really, it's right in the name what that means. It's how much something changes by, written as a percent. So this is just a loose definition of what percent of change really is. It's a comparison between two values over time. Over time is really the important part that we want to focus on. We will always be comparing a new and an old number, and the change will happen from the old going to the new. So a positive percent of change indicates an increase compared to the original value, while a negative percent of change indicates a decrease compared to the original value. And that's really important that we're comparing it to the original value. It's not just how much it's changing by, it's actually compared to the old number. The difference between the new one and the old one compared to the old one. So these are just two examples, and we're just going to talk about what type of change it is. Last week, Kimball, that's my dog there, volunteered at an animal shelter for 12 hours. This week, he volunteered for 15 hours. That is an increase going from 12 to 15. What is the percent of change in the number of hours he volunteered? It will be a positive percent of change. We'll actually find what that number is in a second. Kimball scored 82 points on his first math test of the year. On the second test, he scored a 78. He scored 78 points there. That is a decrease going from the original test, the first test of the year, to the second test. That decreased by 4 points. So you might think that's minus 4 points or minus 4% because tests are generally a percentage, but we're really talking about compared to this 82, what is that percent of change? How much does that 4 actually represent compared to this 82? So to find the actual number for the percent of change, we're going to use one of these two formulas. This is really the simpler one. This kind of lays out exactly what we're finding, but this is the one I'm really going to reference. This is talking about how much something is changing, the actual amount divided by the original amount, divided by the old amount, and that equals the percent of change over 100. So this should not be new at all. We always put the percent over 100, like we're seeing here. The amount of change is really the difference between the new and the old. That's what we're seeing here. The new one minus the old one divided by the old one or the original one. So an easier way maybe to remember this is actually just abbreviating these as no on top divided by the old one. You're using the old one twice, and it's no written across on the top. And again, that equals something that we're very familiar with, the percent over 100. Before we actually get into finding the number for the percent of change, it's really important that we can identify whether it's a percent increase or percent decrease, because that'll decide whether it is a positive number or a negative number as your answer. There's other ways that you can represent this. In addition to saying it's a positive percent of change, you could also say it's a percent increase, and instead of associating it with a negative number, you could actually just say it's a percent decrease, and you don't need to include the negative. So in 2000, there were 365 endangered species. 1 year later, so this is the more recent one, we're going from 2000 to 2001, there are 367 species that were endangered. What was the percent of change? So we can see that that is increasing. That number is getting bigger. So that is a percent of increase. All right, here we're actually going to find that percent of increase. So in 2000, there were 356. That is our old number. 1 year later, 2001. We're not using the years here, but the actual number of endangered species. That is our new amount. And we are going to set this up using that formula. New minus the old divided by the old equals some percent, the percent of change, over 100. So we are going to do 367 minus 356 over 356, and that equals our percent, which is x here, over 100. Our first step has to be to subtract on top. If you type all of this into the calculator, actually if you just do this one side in the calculator, you need to make sure that the calculator follows order of operations here, and you need to make sure that you actually hit enter before you do this division. Instead of doing that, you can actually just solve this as a proportion. So we do the subtraction. That gives us 11 over 356 equals x over 100. And then we can cross multiply. So we subtract, then cross multiply. That gives us 356 x equals 1,100. And the last step is to divide by this 356. That's going to cancel that out and give us that x is 3.0899. I am going to round that to the hundredths place and put my percent sign on that. So my final answer would be 3.09%. All right, on our second example, in Orlando, Florida, the high temperature was 85 degrees on Saturday and 79 degrees on Sunday. So going from Saturday to Sunday, our old day or less recent day is Saturday. Our more recent day or newer one is Sunday. What is the percent of change? So I can see that that's decreasing. So I know this has to be a negative number. Again, I'm going to use this formula. New minus the old divided by the old equals some percent of change over 100. So the new one is 79 minus the old one, which is 85, divided by 85 equals x over 100. So I'm going to subtract on top. That's going to give me a negative 6 over 85 equals x over 100. Now I get to cross multiply. I'm going to change it to black so I can see a little bit easier. So negative 6 times 100 is negative 600. And 85 times x is 85x. And we have one more step. We are going to divide by 85 on both sides. And you can see that this will be a negative number. X equals negative 7.0. I'm going to round that to the hundredths place right away. 0.6. So it was really a 5 and then an 8. So that means that rounds up to a 6. So my final answer is negative 7.06%. Another way to say that is to drop that negative sign and actually just say 7.06% decrease. The decrease is already implying that it is a negative number. All right, this one I'm going to have you try it on your own before I just reveal the answer. So David Dobrik has 25 jelly beans in his pocket, had 25 jelly beans in his pocket yesterday. Today, he has 18 jelly beans. So the old number was yesterday, or 25. The new number is today, or 18. What's the percent of change from yesterday to today? So you can see that that is decreasing. Immediately, you should be able to rule out one of these bad answers. So solve that on your own. So when we subtract, we get this negative 7, but it's not negative 7%. That is the amount of change, not the percent of change. When you find that it's negative 7, that's the number that goes on top. The old number, or 25, goes on the bottom. We cross multiply to get negative 700 equals 25x. And then this last step, we're dividing by 25. And we get negative 28%. All right, one more question for you to solve on your own. Kylie Jenner Sending too many text messages. Sent 180 text messages last week, so that is our old one compared to this week. The old one is a 180. This week she sent 432. That's more recent, so that's our new one. So again, we're going to use this formula. And I want you to solve for that percent of change on your own. Again, thinking about going from this old to this new, does that increase or decrease? Some of these answers you might be able to rule out right away. So once we plug those numbers in, we subtract on top first 432 minus 180, that's the new, minus the old, divided by the old. So that gives us 252. So we can already see that that is a positive number. It will be a positive, a percent of increase. Then we cross multiply to get 25,200 equals 180 times x. And our last step is to divide by that 180. So our x, or our percent of change, is 140%.